we are going to go over another prep assignments over factoring. So in this, I would like to start with some characteristic of polynomials. So if I have minus 5x plus 7x cubed minus 18x to the power 4 plus x to the power 6, we call this expression a polynomial because we have positive integers for the exponent of every term. Let's say if I had plus 7 here, this is still a polynomial because the degree of x for the first term is 1, positive 1. So the degree of the first term is 1. The degree of the second term is 3. This is the third term and its degree is 4. The degree of this term is 6. And the degree of the last term, which is 7, is 0 because I have, for instance, x to the power 0, which is 1. So we say the degree of this term is 0. Then negative 5 is the coefficient for this term. Positive 7 is a coefficient for x cubed. Negative 18 is a coefficient for x to the power 4. Coefficient of x to the power 6 is 1. And this is 7, which is a constant. The degree of this polynomial is 6. We go with the degree with the highest degree, and the highest degree here is 6, so the degree of the polynomial is 6. And the leading coefficient here is 1. So these are some of the things you need to know about the polynomials. Then we are going to go over how to factor a polynomial. So if you have 15 plus 6x, this is what you start with. And they ask you to factor it. And if you know how to factor it, some of the questions will be skipped. But if you don't know how to factor it, the next question is going to go over how to find the greatest common factor among terms. To factor this, you are going to look at the factors of 15, which is 3 and 5. Factors of 6 is 2 and 3. As you see, 3 is the common factor. So if I factor a 3 from 15, I'm left with a 5. So you write the common factor first, which is a 3. Open up a parentheses. That means that 3 is going to get multiplied by everything inside the parentheses. So if you factor out the 3, you're left with a 5. You have a plus sign. If you factor 3 from this term, you're left with a 2 and an x. So now 15 plus 6x in the factored form can be written as 3 times 5 plus 2x. In the previous section, you learned how to distribute 3. 3 times 5 is 15. 3 times 2 is 6x. So these two are the same thing. One is in the factor form. One is not in the factored form. The next question is, they want you to find the greatest common factor among the following 3 terms. You have 35y cubed, comma, is not a polynomial, is just giving you 3 terms. Each one individually could be considered a polynomial, but right now they have given you 3 expressions and they want you to find the greatest common factor. So 35 is made out of 5 and 7. 15 is 5 and 3, and this is a 3. So as you see, I don't have anything in common. They both have 3 here, but this one doesn't have a 3. or these two have 5, but this one doesn't have a 5. So the greatest common factor is 1. In other words, if you had this, if I turn this to a polynomial, if I have the following polynomial, then we say this is not factorable because there is no greatest common factor among them. Okay, so this polynomial is not factorable. But this was the question, to find the greatest common factor among the three terms, the three expressions, and the greatest common factor is 1. The next problem, we have 6x to the power 2 minus 15x cubed, and we want to factor this one. To factor, we know that the greatest common 6 is made out of 2 and 3, 2 times 3. 15 is made out of 3 and 5. And then you also have to look at the x. You have 2 x's here, and you have 3 x's here. And you look for the greatest common factor. The first term has 3 and 2 x's. This one also has the 3 and 2 x's. So you look for the greatest common factor. You look to see what is in common in both of them simultaneously. So they both have 3, and they both have 2 x's, which is x to the power 2. So if I factor that out, I'm left with a 2. So you open up the parentheses, then you write the leftovers. Then you have a subtraction sign. You're taking factor of 3 and these x's, then you're left with 5x. If I multiply this through, I will get the same thing. Okay, so this is how you factor a polynomial. I want to go over another method. So after you find the greatest common factor, you say, well, 6 is divisible by 3, 15 is divisible by 3, 3 is a common factor. In the first term, you have 2 x's. Here you have 3 x's. So x to the power 2, x with the smallest exponent is the common factor. Next, you go 6 divided by 3 is 2. X to the power 2 divided by the common factor x to the power 2 is 1. So you just get 2 times 1, which is 2. Then you say 15, negative 15 divided by 3 is negative 5. You have x to the power 3 divided by x to the power 2. 3 x's on the top, 2 x's on the bottom gives you 3 take away 2 is x to the power 1. So for x's, you're just left with 1x. So that's another way of doing it. The next problem, we have something that looks a little different. We have 2a minus 7 plus 7a minus 7. So for this problem, as you see, both terms have the parentheses a minus 7 as a common factor. So I factor a minus 7 from both of them. That's my common factor. Open up a parentheses. And if I take this away, I'm left with a 2. If I take this away, put it outside, I'm left with a plus 7a. So now I can write this expression as common factor a minus 7 times 2 plus 7a. They're the same thing. So I just want to do one more. If I have 4a minus 2 plus 5a minus 2. A minus 2 is a common factor. They both have an a minus 2. So I take the common factor, a minus 2, open up a parentheses. If I factor this out, I'm left with 4. Put a plus sign, and I'm left with 5a here. So that's how you factor. Now let's go over the next problem. So you learned this one because we want to factor the following expression. You get a lot of problems like this in college algebra. You have to solve equations that look like that, or graph equations that look like that. So you need to be able to factor this. First, you count the terms. You have 4 terms. 1, 2, 3, 4. Every time you have an addition or subtraction, then you have a new term. So you have 4 terms. When you have 4 terms, we have to think of group factoring. How does group factoring work? You take the first 2 terms together, and then you take the next 2 terms together. So you say, what is the common factor between the first 2 terms? The first term has 3 x's. The second term has 2 x's. So x to the power 2, x with the smallest exponent, is the common factor. If I take 2 x's out of this one, I'm left with 1x. If I take these 2 x's out, I'm left with negative 3. So that's how I factored these guys. Next, I'm going to factor the last 2. I have a 5x and negative 15. The common factor between these 2 terms is a plus. You have to connect the red and blue with either addition or subtraction. In this case, I have a plus sign here. I'm going to connect them with a plus. I'm going to factor 5 because this term has a 5 and negative 15 is made out of 5 and 3. So 5 is the common factor. So I write the common factor 5. If I take this 5 out, I'm left with x. If I take this 5 out, I'm left with negative 3. Now, when we get to this point, we look for the greatest common factor between these 2. So now this problem and this problem are the same. X minus 3 and x minus 3 is a common factor. So I'm going to factor x minus 3 from these 2 terms. Now I have this term and this term, the red and the blue. The red and blue have x minus 3 in common. So I factor it out. I open up a parenthesis. If I take this out, I'm left with x to the power 2. If I take that out, I'm left with 5. So now I can write this polynomial that had 4 terms as 2 factors. Let's do another one. We have 4m cubed plus m squared minus 28m minus 7. I take the first, I have 4 terms. I want to do group factoring. I take the first 2 and I take the last 2. The first 2, they have m to the power 2 as a common factor. I have 2 m's here, I have 2 m's here. So if I factor m squared, open up a parenthesis, I'm left with a 4 and 1 more m. If I factor m squared from this one, don't say you're left with nothing, you're always left with something, and that something is this coefficient, which is plus 1. Both of the green terms have negative 7 as a common factor. Remember I told you have to join these 2 with either addition or subtraction. Both terms have a negative, so I'm going to factor a negative. 28 is negative 7 times 4, and the next term is negative 7 times 1. So when Negative 7 is what you're going to factor. Write it as negative 7 times 1. So when you factor your negative 7, you're left with 1, not nothing. You always have to have something. So I'm going to factor a negative 7 from that one. I'm going to be left with 4m. If I factor negative 7 from the next one, I get plus 1. Pay attention here. When I factor the negative 7, I'm left with 1, but that 1 is a positive 1. And test your work. Negative 7 times 4 is negative 28. Negative 7 times 1 is negative 7. So that is just to check your work to make sure you have done everything correctly. As you see, both terms here that have m plus 1, 4m plus 1 as a common factor. So I write the common factor, which in this case is 4m plus 1. Open up a parentheses, then I write the leftover, m squared from here and minus 7 from the next one. Now I want to introduce to you a different kind of factoring. This is called the trinomial factoring because we have 3 terms, trinomial. So we have 3 terms, and the way this factoring works is you say, I would like to write this as 2 factors, like that. So what numbers go in here? What numbers go inside each parentheses? The way you can do this, you say, what 2 numbers I multiply to give me negative 6? So I'm going to open up like a T chart here. Say I want to multiply 2 numbers to give me this negative 6. And when I add them, I want to get negative 5. And negative 5 comes from here. And positive negative 6 comes from here. So that's how you go about these problems. You have 3 terms. The first term has a degree of 2. The second term has a degree of 1. The last term has a degree of 0 because there is no x. Then you break x to the power 2 as x and x. To find out what to put inside each parentheses, you ask yourself what 2 numbers I multiply, it gives me negative 6. And when I add them, I get negative 5. So you start with multiplication, and if you don't know the 2 numbers, just start with 1 times negative 6. 1 times negative 6 is negative 6. Then add those numbers. 1 and minus 6 is negative 5. So that's it. I found the answer. I didn't expect to find it this fast, but those were the answer. So you put this positive 1 in one parenthesis, negative 6 in the other. We are going to practice a couple of these. So that is your answer. We were able to factor a polynomial that had 3 terms into 2 factors. Next, let's say we have x to the power 2. Let's say minus 4x plus 4. I want to write this as 2 factors. Break x to the power 2 as x and x. I want to know what goes in here. The way it works, I open up a chart. I have a positive 4. And in the middle, I have a negative 4. I want to multiply 2 numbers to give me positive 4. And when I add them, I get negative 4. So I start with 1 times 4. 1 times 4 is 4, but when I add them, I don't get negative 4, I get 5. So these are not the factors. How about if I go with negative 1 and negative 4? Because negative times negative is positive 4. But when I add them, I get -5, and these are not it. I keep going. How about if I go with 2 and 2? 2 times 2 is 4, and +4, but 2 plus 2 is +4, and I'm looking for -4. So these are not it. How about -2 and -2? Negative times negative is +4. If I add them, I do get -4. So I put a -2 here and a -2 here. So that's how you factor this one. Let's practice one more. Let's say I have a to the power 2, negative -8 and -2a. So do you see I have a 2 here, a to the power 1 here, and a constant here. So I want to find two numbers to multiply to give me -8. And when I add them, I want to get -2. So -8 when I multiply, -2 when I add. So I can write this as two factors like that. I break a to the power 2 as a and a. Let's see what goes inside the parentheses. If I multiply to get a -8, I could multiply 1 by -8. But when I add these two, I get -7. If I multiply -1 times +8, when I add them, I get +7. What else gives me -8? How about 2 and -4? If I add 2 and -4, I get -2. So I did find the factors. One is -4, the other one is +2. So these are the factors for this polynomial. So please practice multiple problems like that. Now we are going to do another problem, 6y to the power 2 minus 42y minus 54. Before we do this problem, you have to notice that you have a coefficient here. This problem's coefficient was 1, this one's was 1, this one was 1. This one has 6 as a coefficient. The first thing you should do is ask if there is a common factor 6 here, or look for the greatest common factor before you do anything. 42 is 6 times 7, 54 is 6 times 9, so they all have a common factor of 6. So first I'm going to factor a 6 from this one. I get y to the power 2. This is 6 times 7. So if I factor a 6, I get -7y left over. This one is 6 times 9. If I factor a 6, I get -9 left over. So now I want to factor this polynomial. This has a 1 coefficient, and the way we factor it, carry the 6, open up your two parentheses, put y and y inside each parentheses, and again say, I want to multiply two numbers to get -9, and when I add them, I want to get -7. So, to get -9, the numbers are, could be -1 and +9. And when you add, you get 8, not -7. How about 1 and -9? When you add, you get -8. How about 3 and -3? When you add, you get 0. So I can't factor it this way. This is the best I can do for this problem. This part of it was prime, so I can't factor it any further. So you always try to factor further if possible. But if I change that problem and let's say if I had a 48 instead of 42, if this problem was like this, so I'm just going to do another problem for you here. Let's say this was our problem instead. Every term here has a factor 6. I have a 6 here. 48 is 6 times 8, and 54 is 6 times 9. So 6 is the common factor. I keep the 6 out, I get y squared. If I keep that 6 out, I get negative 8y. If I take that 6 out, I get negative 9. Now this has a 1 coefficient. I want to see if I can factor it. I look for two numbers to multiply to get negative 9, and then we add, we get negative 8. Do you see? These are the factors. 1 times negative 9 is negative 9. 1 plus negative 9, if I add these two, positive negative is negative, or you borrowed 9, you returned 1, you still owe 8. So 1 and negative 9 are your factors. So then I was able to write this as 6 times y plus 1, y minus 9. This had 3 terms. I was able to write it as 3 factors. Let's go over another problem. We have 3z to the power 2 plus 20z minus 7. So again, as you see, I do have z to the power 2, z to the power 1, and a constant. But the problem is I have this coefficient 3 here. So I try to see if I can factor the 3 out. But 20 is not, doesn't have a factor 3, or 7 doesn't have a factor 3, so I can't factor the 3 out. So how do I solve these kind of problems when you can't factor? You're going to follow the technique that I explained to you here. You are going to multiply this, whatever this coefficient is, 3, by this number here, 7. That's step number 1. You get 21. So step number 2, you are going to get rid of the 3 and write this expression as z to the power 2, change that 3 to 1, plus leave 20z alone, change 7 to 21. So that's a negative, stays negative. I change 7 to 21. I know how to factor this expression, and these two are not the same thing, but I cheated. I made it look like that because I know how to factor when I have a trinomial with 1 coefficient. So I am going to open up 2 parentheses. I look for 2 numbers to multiply to give me minus 21, and when I add, I get positive 20. So let's look for them. Negative 21, positive 20. So to get 21, you could start with 1 times 21, negative 21. If I add them, I borrowed $21, I returned $1, I get negative 20, not positive 20. How about if I go with negative 1 and positive 21? Negative 1 plus 21, you have $21, you spend $1, you have 20. So these two match, these are your factors, negative 1 and positive 21. You're not done yet. Remember, this was your expression. At this point, you divide these two factors that you found by this number here. Your number here was a 3. You divide both of these factors, these answers, by 3. Then you try to reduce them. You can't reduce 1/3, but 21 and 3 is reduced to 7 and 1. Lastly, you want to get rid of these denominators from the factors so that 3 moves here next to the z. Leave the numerator as 1. This has a 1 denominator. If you move it here, it's just 1z plus 7. And that is your answer. So I want to do perhaps another one. This is also in Alex. I don't know if it has a solution or not. Let's try. So the first thing you do is you say, I have an x to the power 2, x to the power 1, and a constant. But there is a problem here, and the problem is you have a 3. So what do you do with that 3? You multiply it by 20. You multiply 3 by 20, you get 60. You're going to replace that with a 60, and you're going to get rid of that 3. You don't need to write a 1 here. So 20 becomes 60, and then you try to factor this one. You say, I want to get two numbers to multiply to give me 60, and when I add, I get 32. $60 and 32. So to get 60, the numbers are 1 times 60. But now, by now, you should be fast. 1 and 60 is 61. You could get -1 and -60, because negative times negative is positive, and if you add, you get -61. And I should stay away from negative numbers anyway. Yes, negative times negative is positive, but in this expression, everything is positive. So I don't need to look at negative numbers because everything is positive. Then, how about if I go after 2 and 30? If I add 2 and 30, I get 32. Bingo. We have our factors. So I write this as x and x. I put +2, and then the other one is +30. And then I have to remember to divide by this coefficient here. And then you have to reduce. 2 and 3 is not reduced, but 30 and 3 is reducible. So you get 30 divided by 3 is 10. 10 over 1. You move this here and you move this here. So you get 3x plus 2. If you have a 1, you don't need to write it. You don't have to. And when you're working in Alex, you better not write a 1 here. This is not mathematically incorrect, but I don't know if Alex likes you to write a 1 here anyways. So don't write it when it's 1. So that is your answer to this problem. We are going to factor another. We have 9y to the power 2 minus 3y minus 20. We want to find two numbers to multiply to give us a -20 and add to get -3. I'm sorry, no, not now, because let's just take it back, because we can't do that, because we don't have a coefficient of 1 here. So first we have to get rid of that coefficient. You start with trying to factor it. You can factor the 9. So what do? You multiply 9 by 20, which is 180. And then you replace 20 with 180, you replace 9 with 1. So you get y to the power 2 minus 3y minus 180. You want two numbers to multiply to give you 180. And when you add, you want to get negative 3. So to get negative 180, if I go with 1 and 180, 1 times negative 180 is negative 180. But look, when I add them, the difference is massive. So the two numbers must be close to each other because I want to add and get negative 3. If the two factors are 1 and 180, they're too far apart from each other. So when you add or subtract them, you get a huge number. So the two numbers should be closer. To get 180, you can start with 18 and 10. 18 times 10 is 180. One has to be negative. And when I add them, I get negative 8. They're getting closer to each other. If I write it as minus positive 18 and negative 10, I get 18 minus 10, that is also 8. So 18 and 10 did not work. How about if I go with 20 times 9? 20 times 9 is also 20 times negative 9. They're also make 180, but if I add them, I get 11. So that didn't work. What else? For 180, 20, 30, and 6. 20, so to get 880 and to be negative 3, the two numbers have to be super close to each other. 18 and 10 are close. How about 16? I don't think I can write 180. That's 180. Those are prime factors. So how about these two? 3 times 5 is 15. 2 times 6 is 12. So 12 and 15 are the numbers. So if I multiply 12 by negative 15, I get 12 minus, or 12 plus minus. 12 plus minus is the same as 12 minus 15. That is negative 3. So these are my factors. So sometimes it's good to write the prime factors of your number and then match them and just, say I take 5 and 2 together, 3, 3 and 2 together. So right now that's how I found my numbers, 12 and negative 15. So I write it as 12y and y. And then I put positive 12 in one parenthesis and negative 15 in the other. Lastly, I have to remember to divide by 9. So 12 divided by 9, these are reduced. They're both divisible by 3. I get 4 and 3. 15 and 9 are both reduced. 15 divided by 3 is 5. 9 divided by 3 is 3. So remember to move the denominators next to your y. I get 3y plus 4 in the first parentheses. This one is going to be 3y minus 5 in the next parentheses. And this is your answer. So factor negative 3w to the power 2 plus 33w plus 36. We are going to factor the greatest common factor first. That's what you should do. Every time you have a problem that requires factoring, look for the greatest common factor before you do anything. So the greatest common factor is, because my leading term is negative, I'm going to factor a negative 3 from everything. Do you see this is a positive? So I can write my 33 as negative 3 times negative 11. Negative times negative is positive. I can write my 36 as negative 3 times negative 12. So now every single term has a negative 3 as a common factor. So I open up the parentheses. From the first term, I get w squared. From the second term, I get minus 11. From the third term, I get negative 12. So negative 11w and negative 12. And now I try to factor. I want to find two numbers to multiply to get negative 12 and add to get negative 11. So to get negative 12, I start with 1 and negative 12. 1 times negative 12 is negative 12, and when I add them, I get negative 11. So these are the factors. So I come back here, I have the negative 3 gets carried over, open up two parentheses, put w inside each parentheses, and then I put plus 1 and negative 12. And that is your answer. So let's do one more here. We have x to the power 2 minus 6x plus 9. This is 1, so I just go ahead and try to factor it. I want to find two numbers to multiply to give me positive 9, and when I add, I get negative 6. So the numbers are, first I write this as x and x. I look for two numbers to multiply to get 9. 1 times 9 is 9, but 1 and 9 is 10. Negative 1 times negative 9 is 9, but negative 1 plus negative 9 is negative 10. I want to get a negative 6 here. So then I go after 3. 3 times 3 is 9, but 3 and 3 is positive 6. I want negative 6. Negative 3 times negative 3 is positive 9, and if I add them, I get negative 6. So these are the factors. So what was special about this problem? This problem says you have x minus 3 times x minus 3. They're the same parentheses, so you might as well write it like that, x minus 3 to the power 2. So that was the purpose of this exercise. That when the parentheses are identical, you can just write it in exponential form. Then we want to do another type of factoring. This time we want to do look at polynomials that have two terms, and they're called the difference of two squares. So let's say I have a squared minus 9. I only have two terms, and I want to factor this polynomial. So the way this one works, it says if you know square root of 9, if there is a subtraction between the two terms, and this number here is even, like 2, 4, then you can factor this and write it as a and a, just like here. I had x to the power 2, I wrote it as x times x. I have a to the power 2, I read it as a times a. And square root of 9 is 3. You put a 3 here and a 3 here. You make one negative and the other positive. If you multiply a by a, I'm just going to show you that these two are the same thing, because a times a is a squared. a times positive 3 is 3a. Then you multiply negative 3 by a, you get negative 3a. Negative 3 times positive 3 is negative 9. Then you collect like terms. 3a take away 3a is 0. So you get a squared minus 9. So these two are the same things. And this is how you factor expressions that have two terms, a negative sign in between. And this number is even. And this number, you know, it's a square root. So if I gave you a squared plus 9, you say, oh, there's a positive sign here. I cannot factor. So that sign has to be negative. Then let's say I have this problem. How do I factor this one? This is even. I know square root of 9 and I know square root of 4, and this sign is negative. Square root of 9 is 3x. Square root of 4 is 2. So you write it as 3x minus 2, 3x plus 2. Is it okay to put the plus sign here and negative sign here? Absolutely. It doesn't matter which parentheses gets the positive and which one gets the negative. So 3x plus 2, 3x minus 2, if you multiply them, this is what you will get. So let's practice another one. Let's say we have 16m to the power 2 minus 1. Square root of 16 is 4, and m squared is m. So you write it as 4m times 4m. You have a negative sign, that's good. Square root of 1 is 1. So you put a 1 and 1. 1 gets positive, 1 gets negative. So let's say you have 81m to the power 2 minus 25. Square root of 81 is 9m and 9m. Square root of 25 is 5. One parentheses is negative, one gets the positive 5. Let's look at another example. We have 4n to the power 4 minus 64n to the power 2. For this problem, you're going to look for the greatest common factor first. You should always look for the greatest common factor. I didn't look for the greatest common factor for any of these because they didn't have a greatest common factor. But this problem does. I have a 4 here and 4 n's. Over here, I can write 64 as 4 times 16, and I have 2 n's. So both terms have n to the power 2. So both of them have n to the power 2 and 4. So the common factor is 4n to the power 2. If I take this 4 out, and if I take 2 of these n's out, I'm just going to be left with n to the power 2. If I take this 4 and n squared out, I'm left with negative 16. But then n squared minus 16, I have a negative sign. This is even, and that is 16, which I know is a square root. So I can write this as n and n. Square root of 16 is 4 and 4. 1 gets negative, 1 gets positive, and I carry the 4n squared. So that is your answer. That is the answer to this problem. The last thing I want to go over here is we already have done similar problems to this one earlier. I had done problem when we had second root, third root, now we have fourth root. How do we answer this question? You are going to break 625 into its prime factors. 625, because ends with 5, is divisible by 5. So 1 times 5 is 5. 2 times 5 is 10. 5 times 5 is 25. So I can write 625 as 5 and 125. Then 125 is also divisible by 5. If I divide 125 by 5, I get 25. So I can write 625 as 5 times 5 times 5 times 5, 4 5s. Since I'm looking for fourth root, I have 4 5s. It comes out as 1 5, and I carry the negative. Let's look at another example. I have negative 32. This time we're looking for fifth root. If this is odd and this is negative, that's fine. But if this is even, if I has 4 and negative 16, this is undefined. You can have an even root here and a negative under the radical. But if you have an odd number here and a negative, that's fine. Because I can write negative 32 as negative 2 times negative 2 times negative 2 times negative 2 times negative 2. So 32 is made out of 5 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. But since this is negative and this is an odd root, I can write it as negative 2, negative 2, negative 2, negative 2. Since I have 5 negative 2's and I'm looking for the fifth root, the answer is negative 2. Sometimes they write these radicals, like for instance, when I had 625 and I had a fourth, they write it like this. 625 has a 1 exponent, any number, like number 5 has a 1 exponent. So it has a 1 exponent, and that is its root. You can get rid of the radical and write this as 1 over 4. These two are the same thing, different notation. So they just want you to evaluate it and find the answer. So if they give you 625 to the power of 1/4 and they tell you what the answer is, this is what you do. You put the radical, the root is 4, 625 is the radicand, goes under the radical. And then you say, how can I simplify this? Again, 625 is made out of 4 5s. So the answer is 5. So what I'm trying to tell you is sometimes they put the problem like this, and I just want you to know they're the same thing, and therefore they have the same type of solution. They say, what is 81 to the power 1/4? You say, well, this is what I have. And can I write 81 as 4 of the same number? Yes, 81 is 9 times 9, and 9 is 3 times 3. So you can write 81 as 4 3's. Since you have 4 3's and the root is 4, the answer is 3. What about this problem? So for this problem, you have a negative and you have 81 fourth root. I want you to understand, if you have this one, parentheses around negative 81, that means you have negative 81 and fourth root. So this has no solution. It's called imaginary number. But this one, you can simplify, because you know fourth root of 81 is 3, and then you carry the negative. So the answer to this one is negative 3, whereas this one you cannot answer. What if you had negative 125 to the power 1/3? Well, you have a radical. Since the whole thing has parentheses, negative 125 goes under the radical. The root is 3. So then, since the root is odd, you can write that as -5 times -5 times -5. And you're looking for third root. You have 3 3s. The answer is -5.